Once again, I would like to take this opportunity to thank the organizers, as well as the audience for coming out and supporting today. I hope you're all able to hear me. You can? All right, that's a no. All right. Sounds much better now? Perfect, perfect. Now, let's see if I can get this up here. Brilliant. Now, I'm Aldim Facey, and today I will be presenting to you under the topic lactate metabolism and adiposity in elite athletes. And I'll be zooming in more specifically on optimizing athlete selection through lactate metabolism and body fat assessment. But before I delve into the details of this, let me just give you a little background information regarding lactate real quick. All right, now, the lactate pathway for energy metabolism is particularly important for the 200 meters and the 400 meter sprint. It is also important for the 800 meter sprint and for the 100 meter athletes during training. And it has been a very well-studied pathway for all athletes in different disciplines as well. Now, the effect of lactate in contributing to acidosis, and acidosis is basically the buildup of what you would commonly call lactic acid. I'll get into a little bit more on that shortly. And this causes retardation in the functioning of the muscles. Now, oh, what did I do? All right, sorry about that. Now, lactate production begins with a simple process known as glycolysis, which you may be familiar with. Now, lactate is derived from the product of glycolysis, which is pyruvate, and through the action of this occurs through the action of an enzyme known as lactate dehydrogenase, which utilizes hydrogen ions in the process. Now, here's a simple step through. Now, pyruvate being produced from glucose, it utilizes 2 molecules of ATP right here and right here. Now, these are energy molecules and they are used to power the muscles. Basically, when a phosphate group is lost, it is converted to ADP, which is known as adenosine diphosphate, and this provides energy to power the muscles. Now, in the glycolytic pathway, 2 molecules of this ATP is used. Now, there is also a net production of 2 molecules of ATP. So basically, the body sacrifices 2 molecules of ATP to result in a production of 4 molecules of ATP, a net of 2 there, as well as reduced NADH. Now, if conditions require, this pyruvate which is produced, under normal circumstances, it would enter another cycle known as the Krebs cycle or the TCA cycle, which you may be familiar with. And the pyruvate is usually converted to acetyl-CoA, and then in the mitochondria releases more energy. Now, in this case, in cases where you have hypoxia during intense exercises, the pyruvate is then converted to lactate. And as mentioned before, using lactate dehydrogenase and regenerating NAD+, which is then used in the glycolytic pathway right here to produce NADH. Now, lactate is actually what you would actually find in the muscle, because lactic acid, as it is produced, it is dissociated to lactate anion as well as hydrogen ions. And it is the production of these hydrogen ions which causes muscular fatigue. Now, lactate production and accumulation is dependent on several factors, and the rate of glycolysis is one of them. Oxygen-dependent mechanisms, body fat percentage, also levels of fitness determines the production and accumulation of this lactate. Also noteworthy is the presence of monocarboxylate transport systems, and these are basically transmembrane proteins which allow the clearance of lactate, which is also very important. Now, this is a powerful assessment tool as it can determine the athlete's level of fitness. Now, a study was done back in the 1990s where they found that the adipocytes of rats produced 10 to 30% of the lactate in the body, and this is at rest. So glucose that is ingested is converted to lactate at rest by adipocytes. Now, this lactate is cleared using these transport systems here. And now, why am I explaining all of this? Why are we doing this research? Why is this important? Now, the Caribbean boasts the top sprinters in the world, I must say, and ranging from athletes back in the 1940s, you know, with coming up with Quarry, coming all the way up to Bolt, Shelley, and Fraser, and our very own Merlin Ottey. Now, we want to maintain this dominance, and it is obvious that our dominance is surrounded by the sprinting event. Now, we also want to dominate in other areas as well, for example, football. Now, these findings, can provide insights which, if appropriately applied, can legally improve athletic performance. As you know, doping is a major issue. Now, the steps that we took in acquiring the results, we used 35 males, and 19 of which were athletes, 16 were non-athletes, which we would call the control. And these athletes were currently consistently training under a certified coach, and this is very important. And now the control or non-athletic males were of the same age and they were BMI matched. We had to had a controlled environment and ensure that all protocols were observed efficiently. Now, what we did, we allowed the athletes as well as the non-athletes to fast overnight. And in the morning, we take lactate concentration using, as you can see here, the lactate plus analyzer, which just used about 5 microliters of blood using a finger prick. Very easy, very quick. And we also did an after-exercise lactate concentration. Also, we did a body fat measurement using the Harpenden skin fold caliper combined with the Jackson-Pollock skin fold equation, the 3-site equation. And we also used, and this is the Harpenden skin fold caliper, and we also used the Bodymetrix, which is a more modern way of testing the body fat. And it uses a modified version of the Jackson-Pollock 3-site skin fold equation. We also took a blood sample from these athletes to compare their serum lipid profile. So we sent the blood to the lab and have that analysis of the blood done for both athletes and non-athletes. And now, using the Bodymetrix Analyzer, this is a scan, an example of the thigh, muscle, and fat. And here we have the non-athlete. And this is very interesting now because if you take a look at this, up here where you see this light blue area, not sure if you can see it properly from your end, but right up here to about here, approximately 5 millimeters, that would be the fat. And where you see the brightly illuminated areas, those are interfaces. So basically, the ultrasound will have a brighter reflection there where the tissues would cross. Now you have, this is a fat muscle interface, and here you would have a muscle interface where the muscles would overlap each other there. Now, ultrasound, you know, doesn't penetrate bone, so you wouldn't see anything down here. This is where the bone would start. Now, if you look at this, you would notice that, say, the muscle size is approximately, you know, about 30 millimeters, and the fat is about 5 millimeters. And in comparison with an athlete, now this is very interesting. You'll see muscle size approximately 45 millimeters, and the fat layer here is very, 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 very small. You'd have to look really close to see it. Now, we did this assessment, and we also allowed them to run on the treadmill, set at 10% incline, running at a speed of 6 miles per hour for 90 seconds. And this was done for each athlete and each control to ensure that we had appropriate environment to make comparisons. Now, the results that we obtained were very interesting, and this is where it gets really exciting now. There was a significant positive correlation with the basal lactate concentration and the body fat percentage in the athletes. And I will explain this in a little bit more detail in just a couple of seconds. Now, wrong direction. When comparing the body fat percentages, we had some expected results. The body fat percentages of the athletes were lower than those of the control. The control had about 10.2%, while the athletes had 8.2% on average. And these athletes, we used discus throwers as well, who had higher percentages where body fat is concerned. And this can be an advantage for them because in their sporting area, very low body fat percentages is not necessarily an advantage. And I will explain that also briefly. And for the blood samples, we did a serum lipid profile comparison here. And as was expected, for the, I'm so sorry, but not seeing the bottom here. These bars here represent the total cholesterol level. For the non-athletes, they had a higher cholesterol level in comparison to the athletes. This bar here, displays the LDL cholesterol, and this is often referred to as the bad cholesterol, and it is lower in the athletes in comparison to the non-athletes, which goes again to verify that for persons with high cholesterol levels, it is important that you exercise, as exercise does have a positive effect on that. And here you have the HDL cholesterol, which is known as the good cholesterol, and it's not significantly different, just slightly higher for the athletes here, and there's no significant difference with the triglyceride levels when comparing the serum lipid profiles. Now, a comparison of the average lactate concentration here now. The basal lactate, post-exercise lactate, and the change in lactate for the athletes in all cases were lower. This indicates a higher level of fitness. And I'm happy that the results came out like this, as they do not conflict previously published data. Very interesting results here, and I'm sure you're getting excited now. Now, the results, as was mentioned before, had a Pearson correlation of 0.615 and a p-value of 0.005. Amazing. And this is for the athletes. And this is for the athletes here. Now, this correlation indicates basically that there is an association with body fat percentage and the basal lactate concentration. So instead of having the athletes run in order to determine their levels of fitness, we can have them do the basal lactate concentration as well as body fat in order to create an optimum profile for them. All right, now running out of time, let me move along really quickly. The positive correlation of body fat percentage was also confirmed in the control sample, and this verifies that the procedure was taken out correctly and that the methodology does work. The control samples had a p-value of 0.026, and if you're familiar with statistics, you would know that this is also very significant. Now, with this result, we can make reasonable conclusions that increases in body fat percentage can lead to significant production of lactate at rest. Now, this basal lactate is particularly important to athletes as it can determine their level of fitness, and this information is important to coaches as well, as they can use this to monitor the progress of their athletes throughout their training sessions. Now, also, lactate, though it is associated with muscular fatigue, through the production of hydrogen ions, and it can be used also as a fuel for skeletal muscles, such as the heart can use lactate as well as the red skeletal muscles. However, it is not an advantage to have lactate building up. So you have to keep the lactate concentration under control at a very minimal level. So for each sporting activity, there's an optimum body fat range and an optimum basal lactate range, which must be considered when selecting athletes. Now, the lactate concentration profile, as well as the body fat profile, would make athlete selection much easier. And this athlete selection that we make reference to is across different sporting areas and within the same sporting areas as well. For example, you know that Usain Bolt originally was a 400-meter runner. Then he came down to the 200 and 100-meter runners events as well, and he performed much better at these events in comparison to the 400-meter run. So in optimizing, moving ahead here. In optimizing athlete selection, we must take into consideration the athlete's profile so we can determine whether they'll be more suitable for a certain event. Now, while we dominate the sprinting era, we can also dominate the football as well and other areas if we optimize the selection of these athletes. And that will be all, and thank you so much for listening.
Thank you for showing us this interesting data. I hope there will be a lot of discussion about this, as the matter is very controversial. And the next presentation will be made by Ms. Salendi, who is an undergraduate student of the section of Human Nutrition and Dietetics, Faculty of Food and Agriculture, UWI, St. Augustine. The title is What Color is Your Urine? The Effect of Exercise on Hydration Status in Student Athletes. Please, Ms. Salendi.